Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to go over a couple of practice problems dealing with constant pressure calorimetry, where we are going to find the enthalpy of a reaction based upon certain information we're given with a reaction in a coffee cup calorimeter. Before that, let me fix the lighting here. That's better. Okay, so the first problem, we're given that magnesium reacts with hydrochloric acid to form magnesium chloride and gaseous hydrogen. and So we're given a certain amount of magnesium. We're given 0.158 grams of magnesium solid, and that's going to react with enough hydrochloric acid to give 100 milliliters of this solution. Okay, so we're going to have 100 milliliters of the solution when the reaction is done. So we have enough of hydrochloric acid to react completely with the magnesium. And so we're given an initial temperature of 25.6 degrees Celsius, final temperature of 32.8 degrees Celsius, and we're asked to find the delta H of the reaction. Now, the thing we want to remember is the delta H of the reaction is always going to be some energy unit per mole, usually kilojoules per mole, but it could be joules per mole as well. But we'll convert it to kilojoules. We'll notice here that we're in joules here. Okay, so they're giving us the density of the solution as 1.00 grams per mil. You might recognize this as the density of water. So we're assuming that the density of the solution is the same as water. Same for the specific heat of the solution. So they're giving us the specific heat of water, so we're assuming that it's the same as water. Okay, so when we're doing this problem, we want to figure out the equation. And as I said before, you want to set it up so that's equal to 0 times Q1 plus Q2 plus whatever. The only thing going on in this problem is that you've got the reaction going on, and you've also got the solution as well. So those are the only two things. So the reaction is the system, the solution is the surroundings. So this will be Q1, Q2, and so this is going to be Q1 will be the Q of the reaction, plus Q2 will be the Q of the solution. And so the Q of the reaction is just going to be the heat from the reaction that we're going to get from the reaction itself, given that we have this amount of magnesium. Okay, so so here the Q of the solution is going to be equal to the mass of the solution multiplied by the specific heat of the solution multiplied by the temperature change, which is going to be final temperature minus initial temperature there. So there's my equation for the Q of the solution. The Q of the reaction is the heat that's either absorbed or emitted by the reaction itself, but that's what we need to find if we're going to find the enthalpy of the reaction. So this is what we're going to be looking for. So if we plug everything in, so 0 is equal to the Q of the reaction plus, and then we substitute this in for Q of the solution, the mass of the solution multiplied by the specific heat of the solution, and then multiplied by the final temperature minus the initial temperature. So we know everything except for Q of the reaction. That's what we're going to find. So then we plug in the mass. So 0 is equal to Q of the reaction plus, and then we're going to have 0. Oops, my bad. So this is going to be, this is the mass of the magnesium. We want the mass of the solution. So to get the mass of the solution, we have to use the volume of the solution plus the density of the solution here. So what we need to do is we take the 100 milliliters of the HCl solution, and we're going to use the density as a conversion factor. So we have milliliters on the bottom, so we're going to have 1 milliliter of the HCl solution on the bottom, and then we're going to have 1.00 grams of HCl solution on the top. So milliliters cancels out, we're left with grams, so it ends up being equal to 100 grams of HCl solution. So we're going to use 100 grams, so that's going to be 100 grams of the HCl solution multiplied by the specific heat, which is 4.18 joules per gram degrees Celsius, and then final minus initial temperature. The final temperature is 32.8 degrees Celsius minus the initial temperature, 25.6 degrees Celsius. And so we're going to use our equation to calculate this, but one thing you should notice is grams cancel out, and then the degrees Celsius are going to cancel out as well. So now that we have those canceled out, let's calculate the answer for this part. So 100 times 4.18 times, and then we'll have 32.8 minus 25.6 equals, and here we get 0 is equal to Q of the reaction plus 30,000 and that's going to be 3009.6 joules of energy. And you'll notice it's positive, and that means that it's positive for the solution, which means that the solution gained energy, which means that it should be negative for the reaction because the reaction lost energy to give to the solution. And that's what you're going to get, because if you bring this over to the other side, then what's going to happen is that Q of the reaction is going to be equal to negative 3009.6 joules, right? And if we change that to kilojoules, then if we use this space over here, we'll change 3009.6 joules. If we convert that to kilojoules, so that's going to be 10 to the third joules is equal to 1 kilojoule. Joules cancel out, and then you end up with 3.0096 kilojoules. Okay, so that's the amount, that's negative. So, and that's the amount of energy produced by the reaction. But this we need to say per mole. So this is the total energy, but it's not energy per mole. The delta H, or enthalpy of a reaction, is always kilojoules per mole. So that's why they gave us the 0.158. So we're going to have to convert 0.158 grams of magnesium to moles. So we're going to use the molar mass of magnesium, which is 24.31. So 24.31 grams of magnesium for every 1 mole of magnesium. So the grams of magnesium cancel out. I'm left with moles. So if I use my calculator, so I have 0.158 divided by 24.31 equals, and that's going to give me, that's going to be 0.006499 moles of magnesium. So now that I have the moles of magnesium and I have the total amount of joules or kilojoules here, now I can do kilojoules divided by moles, and that's going to be the delta H of this reaction. So if I do that, so if I have negative 3.0096 divided by 0.006499 equals, and then so that means that if I write it over here, the delta H of this reaction is equal to negative 463.0866 kilojoules per mole. And again, going back to our significant figures, we need to make sure that we're doing our significant figures right. So remember here, this is our, we're subtracting, so we're looking at the number of decimal places. They both have 1 decimal place. So if you subtract those from each other, so 32.8 minus 25.6 equals, and you get 7.2. So 7.2 degrees Celsius was the difference here. So that's 2 sig figs. 2 times 3 times, I think this is going to be 100 grams or from 100 mils. So that's going to be 3. So the lowest number is 2. So 2. So that means that our final answer should be in 2 sig figs. So where's our answer? So our final answer was here. So we had 2 sig figs when we divided. So our final answer should be for negative 460 kilojoules per mole. So that is the delta H or enthalpy of the reaction. I hope this was helpful. If you have any questions, put a comment in the comment section. Is there anything else you want me to cover? If you enjoyed this video, if you thought it was helpful, share it with others, share it with your friends. Hit the notification bell if you have, if you want more videos to be notified about any videos I put out. Hit the subscribe button, and thanks for joining me. I'll see you next time.